So this is Alum crystals part 1, still waiting. The reason that we're still waiting is I haven't seen any crystals start to form in this vial yet. Let's see if I can get this. Yeah, there's nothing in there. It's maybe a little bit dirty on the outside, but there's nothing in there. So maybe a little bit less water than there was at the end of lab on Tuesday. I think probably some of the water's dissolved out, but anyway, the first step to make the alum was dissolving aluminum foil and 4 molar potassium hydroxide. We tore aluminum foil into small pieces and placed these pieces in a beaker containing the acid. The resulting mixture was dark gray but became nearly clear after vacuum filtration. We then slowly added 9 molar sulfuric acid to this solution. Initially, aluminum hydroxide precipitated out into the solution, creating a slushy mixture, but additional sulfuric acid caused this to mostly redissolve. To encourage as much aluminum hydroxide to dissolve as possible, we heated and stirred the solution for over 10 minutes. When the solution was clear, we let it cool for a couple minutes, then submerged it in an ice bath. Since alum dissolves at a higher temperature than aluminum hydroxide, aluminum preferentially precipitated out when this temperature was reached by cooling. The alum precipitated out and we cleaned the product with vacuum filtration and a 50-50 water ethanol wash. Once dry, we measured out the correct weight of alum to create a saturated alum solution at 20 degrees Celsius, which was the approximate temperature of the lab that day. Finally, we poured the mixture into 3 of these vials here and capped them with Kim wipes, as you can see, and rubber bands too. As the water slowly dissolves out of the test tube in the coming weeks, the solution will become too concentrated to support the amount of alum in there, and the alum will begin to precipitate out, forming a crystal or perhaps a few crystals. It's hard to say, hard to know. To make crystals of NaCl, on the other hand, I would add salt to water while stirring until the salt no longer dissolves. Then I would filter the undissolved salt out using gravity filtration, like we did at the end of the lab on Tuesday. Finally, I would add my filtered saturated solution to a vial and cap it with Kim wipe. As the water slowly evaporated, an NaCl crystal would begin to form. Another way to make crystals is using Epsom salts or magnesium chloride. According to Liam Riggs, a middle school science teacher, in his video Making Crystals with Epsom Salt on YouTube, the recipe is 1.5 cups of Epsom salt and 1.5 cups of boiling water. You mix these together until the salt is fully dissolved. You suspend a piece of string in a mason jar using a washer to weigh the string down. Suspending the Tide washer about 1 inch from the bottom of the jar, you add the magnesium chloride solution and wait. In a few hours, you will find the magnesium chloride crystals developing at the end of the string.